Right, welcome to the latest edition of VQMS. Today, Tong's going to be presenting a combination of two projects using LLMs to improve task robustness, applications and customer service, and content marketing. So the way the seminar will work is there's going to be 60 minutes of the formal seminar. We'll hang back for 15-30 minutes after just for informal chat. During the seminar, the panelists can just unmute themselves and ask questions. The audience can ask questions using the Q&A box at the bottom of the screen, and I'll compile your questions and relay them to Tong as she presents.
Yeah.
All right. Tong, you can take it away.
Okay, let me share the screen. Oh, can you see?
Yes.
Okay, great. Okay, so today I'll talk about two projects. I think I choose to talk two of them because I think it's pretty much under the same theme. So that's why I want to talk about, especially the first one is a complete project. The second one is still ongoing. So I'd like to hear any of the feedback if you have any. So the first project is in collaboration with Professor Sudhir, and that was a postdoc at Yale, and he recently joined NVIDIA. And then the second one is an ongoing project with Sudhir and a pre-doc. Okay, so the title is called Using Embedded Knowledge in LLMs to Improve Task Performance, and the application in customer service and content marketing. So we know that LLMs, they have been trained on extensively on very different data sets, many different data sets. So it possesses very rich knowledge. For example, they have very diverse understanding. They can answer questions on science, history, coding, and more. They also have context awareness. They understand and can generate text based on the previous context. They also have very great human-like or even beyond human-like problem-solving abilities. The reason they have that is because they have seen so many data. So these data are now basically consolidated into the knowledge, which is reflected by different parameters, right? Billions or even trillions of parameters. So the thing I'm interested in is that is it possible to elicit the knowledge for a relevant task? What I mean by knowledge is like the text description of the know-hows or strategies or guidelines or explanations for a specific task we're trying to solve. So one motivation for that is because we're curious. We want to understand what exactly did LLM learn for this like the ocean of data. The other thing is that if we humans know this knowledge, it can improve some understanding of the task and then improve the decision making. So I show an example. This is not exactly from LLM. This is from the AlphaGo, right? The AlphaGo, they play better Go, and then people basically generate the game sequences. They study the game sequences to improve their strategies of playing Go. So we can actually learn from this knowledge. So how are we going to use this knowledge if we're able to extract something? So the first application I talk about is we will distill the knowledge into a smaller LLM to improve the performance, specifically in the application of customer service. So the motivation here is because many times you don't want to use state-of-the-art black box LLM because maybe for the security reason, you want to self-host a LLM, right? Especially if it is accessing your customer data to interfacing with your customer. So you want to have some control of the LLM. But if you use your smaller LLM, there's usually a performance gap. So we talk about knowledge distillation of improving the performance, utilizing what we call the teacher LLM, which is a state-of-the-art LLM, such as like GPT-4o or DeepSeek. The other application is that suppose we want to fine-tune a smaller LLM. So is it possible to utilize the knowledge from a better LLM to try to regularize or guide the alignment to improve the performance? And specifically, the most interesting that across the two applications is that how do we elicit knowledge for different tasks? Okay, so let's start with the first application. The first application is knowledge distillation for a smaller LLM to work as a customer service agent. The motivation for that is, I mentioned the security. Another motivation is the price, right? The LLMs, there are many different versions, but they differ in price and performance. Usually there's a positive correlation between the price and performance. Otherwise, there's no point of charging more, right? Who's going to pay for that? So the question is that can we improve performance of low cost or even free? Free means that you basically self-host. So you only pay for computing and storage. You don't actually pay per query. Can we improve these smaller LLMs using a better, the state-of-the-art LLM? And we'll illustrate in the context of customer service chatbot application. So why do we care about using a lower cost LLM, right? How different is it from if we charge $1 versus 0.8 or 0.9 versus 0.7, right? So it's actually this a big industry. There's big spending on customer service. So if you look at the annual US customer service spending, it's about 350 billion. The advertising is only 300 billion. So think about the volume of like the customer calls. So you actually spend a lot of money on it. So that's why there's strong motivation to cut down the cost by using a cheaper LLM. So before I talk about our framework, I'll give you some background on knowledge distillation. This phrase is not new. This idea was originally proposed in 2015 by Hinton. But back then, they were just building a classification model with the goal to basically utilizing smaller model. The goal is model compression. So they're trying to use a smaller model to mimic the behavior of a larger and more complex teacher model, and such that it reduces the cost. And what they call knowledge is, in fact, the predicted probabilities, and they call it soft labels. And the reason that the knowledge distillation helps is that the soft labels actually provide information about the decision boundary than the actual classification labels in the data, right? So if you train the smaller model on the soft labels instead of the classification labels, you're actually getting more information. And that information is being extracted by the larger, more complex model. And that's why this method works. And they have proved that if you train a smaller model using the teacher's output, it'll actually perform better than if you directly train on the ground truth data. And then, since 2015, now we fast paced to today's world of large language models. So the idea has been extended, right? So if you think about knowledge distillation, there's usually two stages. The first stage is knowledge elicitation. In the past world, the knowledge elicitation is basically just building a classification model and getting a soft label. But for LLM, there's more a rich definition of what is considered a knowledge. For example, you could just get the LLM to generate training data, right? You could like work with no data, a very limited data. And by interacting with the LLM, by writing prompt, you can elicit data. That data can be considered as knowledge. Or you could also get some feedback or get some reward signal from the LLMs. And for a specific context, for example, directly get the responses from the teacher. And the thing that we propose is that we consider not just the training data as knowledge, but also we want to elicit the strategies customized for each particular student model and adaptive to different scenarios. We consider that as the knowledge. And the stage two of any knowledge distillation is the distilling the elicited knowledge into the student LLM, right? How you infuse the learned knowledge with your LLM. So in the Hinton paper, he basically trained the student model, right? Now this idea has been inherited, and when people distill the knowledge into a LLM, they do fine tuning. So the knowledge is reflected by changing the parameters of the student LLMs. So what we propose is that we don't fine tune, we don't change the parameters of the model. So we will use a rack-based approach where we store the strategies in the library. And whenever the student encounters a similar scenario, he'll basically use the most relevant strategy from that teacher. And there's actually some motivation for doing that. I'll talk about in more detail later. So based on this background of knowledge distillation and the comparison with ours, I will show you the overview of our proposed knowledge distillation procedure. Stage
Tong,
one. So yes.
I have a few questions about the cost motivation.
Yeah.
So the scenarios you're comparing here are scenario one is I use GPT, I use a big model and I perform inference and I pay their per token cost.
Mhm.
That's option one. Option two is I use a distilled model using your approach. That distilled model, it's going to be self-hosted. Is that correct? So there is
Either
no.
way, it could be queried from a third party. yeah, if you're not concerned about security, you're only concerned about the cost,
Yeah.
then you can just query and it will cost cheaper. And
Okay.
otherwise, if you are indeed concerned about security, then you will self-host. So yeah, so no other company can access your data.
Okay, got it. So then you reduce, let's say you reduce the inference costs to zero or some small number, but then the trade-off is that your distilled model is, I guess, you need it. It's probably going to reduce the downstream decision-making performance somehow.
Yeah, it will because it's smaller, right? Because it's certainly worse than GPT-4 or DeepSeek. So there's a trade-off. So the goal of this application is how do we improve the smaller LLM utilizing the state of the art, whether it's GPT-4 or DeepSeek.
All right. So you maintain the decision-making performance and reduce costs at the same time.
Right, right.
Thank you.
Yeah. Okay, so the stage one is still knowledge elicitation. So here what we do is that we feed in a base prompt. The base prompt describes the problem and the role of each agent. For example, it could say, now you role play as a customer service agent, and your goal is to make customers satisfied, and so on. And this plus an input. The input is an ongoing conversation between the agent and the customer, and ending with the customer. So the agent needs to say something. So with the same base prompt and input, we feed it into the student and teacher, right? So we know that teacher is better because we choose teacher to be the state-of-the-art model. For example, GPT-4 or DeepSeek. And now we used green to represent teacher and blue to represent student throughout this presentation. So, and each of them will provide a response, right? And we already know the green output is better than the blue output. So what we can do is that we can ask teacher to compare the two outputs, right? To work as abductive reasoner, right? We tell the teacher, this output, green is better than blue. And then you want to propose some suggestions to the teacher LLM, as the student LLM, such that it will respond more similarly to the green output, right? So these strategies are represented as a list of do's and don'ts, for example. And these will be incorporated into what we call the strategy prompt. And then the strategy prompt will be combined with the base prompt, right? So basically we updated the prompt. Now with the new prompt, the student will say something differently and hopefully more similar to the teacher's. And then the teacher will compare again. So it is an iterative process. Now every iteration, we're adding something new to the strategy prompt, trying to catch up, to catch what differentiates the two. And eventually it will stop. So there are two stopping mechanisms. Either the teacher says, the answer is pretty much similar. There's no advice I can give. Or we actually also build a scoring model, and then we evaluate how good the performance is. If there's no improvement in the score, then we say it is basically plateau. There's no improvement.
Tong,
So this is how we, yeah.
sorry, do we use ground truth data in this elicitation stage at all?
What do you mean ground? Do you mean real data?
Do we observe the actual label of the actual output?
No, in this case, there's no real world data of rating. So because we assume that the teacher is better because we know that it is the state of the art model. So there's no human labeling in this case, but it will be easy to incorporate one. Like if we know, if we have them like as human labeled textbook answer, like we will use that to replace the green output. And the teacher will only act as like a grader. He will not be providing answer, but he will be grading. Yeah.
So just one clarification question. It's a new instance of the teacher, right? That does this strategy.
I'm sorry, it is what?
It's a new instance of the teacher that does the strategy, right? It's not the same instance that created the output that you later say, then compare these two. It's a new instance.
It's a new, what do you mean new instance? It's the same input. This is a training procedure.
I understand, but like you ask a question, it has two outputs. You can go to the same instance that generated that output that has still the history and say, compare this output with this other output I got, or you can instantiate, like you can start with fresh history.
No, oh, you mean during the training process?
Yes, during the training process, it's a fresh new instance, right?
It's a fresh new instance, but we still feed in the same input. like
I got
the
it. But like
protocol.
once the output is generated, I want to use the teacher to create a strategy. It's a new instance.
It's a new instance, so
Got
he
it.
does not know what happened in the previous iteration, but he does see the input, which is the same fixed ongoing conversation.
Okay.
Yeah. Okay. Okay, so then, for each input, we basically pair it with the best strategy, right? So this is only one strategy. And imagine we will create many different pairs, right? And then hopefully that cover the data space of many different scenarios. And I'll talk about that later, okay? I just want to give you some overview. And then we store everything in what we call library. You can think of the library as the list of many different pairs of conversations or scenarios paired with the best strategy. Okay, and why don't we just fine tune it? The other thing we can do is that we can just get the answer from the teacher, right? Get their response, and then the input. We can directly fine tune instead of creating the strategies. Why don't we do that? The motivation for that is because the research from a couple of years ago, and you can see there are two lines here because I hit the other one in the other lines. There are two lines. The green represents prompt tuning, meaning that you will try to optimize the prompt instead of changing the model parameter. The orange is model tuning, which means fine tuning. You actively change the parameters of the model. You'll see that when the model size is small, model tuning is better, which means if you have a really small model, you want to do fine tuning. However, as the model size becomes a little bit larger and larger, prompt tuning is actually becoming better and better to the point that it could be better than model tuning. And so what models do we use? We're actually using Llama 2 7B, 13B, 70B, and GPT 3.5 in this experiment. So you can see that they basically pass the point where prompt tuning is better. And our method, the way we use it is include a strategy in the prompt. So it's very similar to prompt tuning, right? We basically optimize the guidelines or instructions in the prompt. So that is why we want to use like a RAG based rather than fine tune it.
Tong,
Yeah.
isn't the distilled model going to be much smaller? Like
Yes.
I assumed it's going to be like in the 10 to the like less than a million parameters, or I don't know how big is the distilled model?
We tried, yeah, these are the models we tried, 7B, 13B, 70B,
Oh,
175B. Yeah, this is the model we tried. Yeah.
uh, I'm kind of okay because Llama 2 7B is it's like reasonably okay. If you're self-hosting, it takes up quite a bit of GPU RAM. That's why I was surprised that this is a distill model. But I guess if you host it somewhere else and just do inference, yeah, it's cheaper. Yeah.
Yeah. Yeah. And we actually don't need to train any of them. So yeah, I agree. Training is a hassle. Like if we actually for another project, the reason we only use 3B, Llama 3.2 3B is because our GPU cannot train
Yeah.
even like 7B. So that's
Yeah.
why, actually this type of distillation of not training will be very helpful if you have a computing resources constraint.
Thank you.
Okay, so if our knowledge distillation approach works, what are the benefits? So first of all, we only need API access. In both training and doing inferences, there's no need to access or change the parameters of the LLM. So it can be applied to any LLM. As long as you can query it, you can apply. And the other thing is that the benefit is that it is interpretable. So the strategies are text. So human can understand it before you deploy this library, especially if it is interfacing you with your customer. You can actually look at what strategies are used, right, to see if it violates any of the company policy or any of the ethical considerations. And the third benefit is that it's transferable, right? Because there's some common principles in the knowledge, which is transferable across student LLMs and even across problems within the same category. So we will show that in the experiments. And finally, it is dynamically adaptive to different scenarios. So that works better than some global guidelines. Okay, so let's talk about the method. In the entire project of the method development, because we're using knowledge distillation to elicit data from the teacher LLM, there's no real data involved. Okay, so not all the knowledge is purely simply only from the teacher LLM. So we have to simulate an environment, right, such that we can get the appropriate conversation, like just like in the real world from the teacher LLM. So in order to do that, we use another agent, which is like a customer agent. Here we use GPT-4 to simulate as a customer agent. We basically describe the problem to the customer, saying, for example, you're trying to call an airline company, and your goal is to cancel a restricted ticket. And restricted tickets are tickets that are not edible, not refundable. So of course the agent will say no. But then what's interesting for us is that how they say no in the different way, even though they have to provide pretty much the same solution. And when we simulate the customer, in order to basically simulate different types of conversations, we will change some components in the prompt. For example, we change the social style of the customer. Their initial emotion, are they coming with more like puzzled, confused, or slightly frustrated, and so on. And whether they're being demanding. And we notice that if we put the word demanding in the prompt, they will be more persistent in getting a response.
Tong, can I ask another clarification question?
Sure.
So is it the training is always one shot, right? There's an issue and there's a one-shot response. You have the expert or the teacher and you have the student. You create these strategies. It's always like a one-step thing, right?
One step in terms of yes, when you learn the strategy are iterative, but it's at that particular step, particular
So
time step.
the reason I'm asking this is I'm just curious about the way you train this. Is there reason to be concerned that the quality of answers deteriorate as the agent and the customer start interacting?
Yes, that's a great question, and I will show that we considered that when we generate the data.
Okay.
Yeah, but that's a very valid concern. Yeah. Okay, so this is the customer, and then we simulate the agent using the teacher or student LLM, right? And there are two requirements. First of all, they have to adhere to company policy. Otherwise, if their goal is just to make customer happy, they will agree to whatever they say, right? If they say bump me to the first class, they will say yes, right? If they say cancel the ticket, they will agree. So we have to control the solution such that the difference is only in their communication style. Okay, let's talk about the knowledge elicitation part. And I've showed you the overview, but let's put it in the context here. So the input is what we call the scenario. It's ongoing conversation ending with the customer. And with that, we send it to the teacher with the base prompt, which describe the problem and describe the goal and the policy. And the teacher will provide an answer. And because we already know teacher is a state of the art, so this will be thought as the textbook answer. However, if you do have the real data, then you can easily replace it with a real agent's response. And then with the same base prompt, we feed it to the student, and we know the student is inferior. So there's actually a difference between their responses. So the teacher will compare the two and create a set of instructions, and these will be incorporated into the prompt. And now the prompt is updated. The student will update the response. And then this response will become more similar to the teacher's, but not exactly. So there's still room for improvement. So the teacher proposes a new set of strategies, which is incorporated. It is an iterative process. And at the end, this is the output of this algorithm, an updated prompt paired with a scenario. So this is just one case. And we need many, right? Because we need different scenarios generated. And to do that, we vary the personality, emotion, difficulty, increase the temperature so there is no diversity in the output to create many different conversations. And we extract scenarios from them. For each scenario, we repeat the strategy learning algorithm. What we get is a library that looks like this. Okay, so how do we use it? When we deploy the student is hooked up with this library, customized for that student. So when the customer said something, which creates a scenario, and we will look for the most similar scenario, most similar in terms of their embedding space being the most close to each other in the library, and activate the corresponding strategy. Now, on the strategy, the student will say something, right? And then the customer will reply, which creates a new scenario, okay? And so on. So this is how the very basic idea, basic framework, how it works. And then I'm going to answer Ali's question. Are the generated scenarios good enough for the student? And why it is not like that in this context? Now, before I show you a solution, I want to show you the result from our human evaluation. So these are the conversations generated between a customer agent with two different LLMs, Llama 2 7B, which is a worse LLM, and GPT-4. When we do the evaluation, we show them to a human participants, and one of them made this comment. He said, "Appear two, agent two, which is GPT-4, appears to be more concise and clear, though it does seem like agent one was dealing with a more difficult customer." We thought this comment very interesting because we know it is exactly the same customer in the sense that it is the same prompt and same LLM. So why did the customer appear more difficult with agent Llama 2 7B, right? So this is because, the teacher, if you generate every scenarios only by the teacher, because the teacher is high standard, highly skilled, and he's able to make sure the customer is all happy and calm and composed all the time, right? So you will be getting scenarios that are considered relatively easy and, cheerful customers. However, if you deploy a model that is worse than the teacher, even if you just deviate by a little bit, right? And you will get the customer to lead to a state that is slightly different. And then as the conversation goes, because there's approximation error, right? You'll get what we call compounding error. Every time you made a little bit of mistake, and then gradually you will be deviating away from the regional states. You will lead to the scenarios where the customer is all frustrated and pissed off. Okay, and these scenarios are what the students have not seen during the training. And this is distribution shift. So there's got to be a way to deal with that. So that's why when we generate the conversations, it is important to make sure that not only teacher participate, actually there's an increasing chance for the student to participate. So we do this scenario generation iteratively every time with a batch. And then in each iteration, the teacher is selected with probability gamma to the t. T is the batch indexed. Gamma is a probability. So as t increases, you see that the probability of selecting teacher decreases. And then the probability of selecting student is 1 minus that gamma to the t. So it naturally increases. So essentially, the generated conversation will cover a large spectrum and bridging the gap between the training data and test data. And we will get the library where the scenarios are generated by both. Okay? And
Tong,
this is the overview. Yes?
so when you're comparing the two responses, in your approach, you ask the teacher to give a comparison in natural language.
Yeah.
And that could have some errors, right? So the teacher is comparing two pieces of text, and hopefully the teacher is able to figure out these are the most important differences between the two. But it
Right.
could happen that the teacher misses some differences or highlights differences that are not very important. And I saw that in a previous slide, you asked a human to compare
Yeah.
the two responses. So do you have a benchmark of that kind where you look at what the strategies that the teacher comes up with and what a
I
human
see. Yeah, that's a great suggestion. We didn't do that, but I think that's a great suggestion. Yeah. Okay, so this is the overview. So it is iterative process. In each iteration, we sample a batch of scenarios, learn their strategy, add to the new library, and then we cannot keep growing, right? If you keep growing, yeah, you'll get a better, more larger library, but it doesn't necessarily help after a certain point because it will saturate. Okay, so we have to evaluate how good the library is. So we basically evaluate the student with the current library, and if there's no improvement, it means that it already saturates. Zhenling, you have a question?
Yeah, just out of curiosity, in the library, at each time you select one scenario that matches the current conversation.
Right.
I'm curious of how much the strategy overlaps in the different scenarios, and if there's a benefit or reason to kind of have a more condensed overall good strategies to use when interacting with a customer instead of relying on one thing that matches the.
Yeah, that's a great question. So first of all, generally, I think that if you add more scenarios and strategy, it doesn't hurt. But after a certain point, it stopped adding value because the ability of the LLM, they are very good at generalizing. Even if the scenario is not exactly the same, the LLMs are very good to borrow the strategy and adapt to his own context. So as we add more scenarios there, the strategy actually will become more and more similar. So that's why it stops adding value. Yeah. I saw a hand raised. Minha Huang. Minha, I saw that he raised hand. Okay, that's fine if we.
I'd have to promote them to panelists. Oh, but in the meantime, so the audience members can leave questions.
I saw that some of the audience raised their hand, so I cannot really see because I have full screen. So maybe Emma, can you help me to see who
Yeah,
has
you can continue. I'll figure out how to
Okay.
how to promote them. Yeah.
So I
Okay.
filled the space with the question. So it's very interesting, this idea you have come up with, that you want to inject data from the sort of student as well to cover the space. I have another question. It's just out of curiosity whether you have thought about this. Should we also think about some form of adversarial customer to cover the space better, right? The customer also tends to, if your customers, I think the way you're going to train this is their customer is also an LLM, right? You
Yes.
have an agent as a customer.
Yeah.
Should we do something there? I don't know. Have you thought about that?
Adversarial. We can
Not even
vary
adversarial,
anything.
but you can see that if you want to cover the probability space, this is space, you have injected this sort of quote unquote randomness by including the teacher. The
Yes.
student, sorry, so many words. But should we do something about the customer? I just don't know. I'm just asking.
Yes, we did. So here we vary the personality.
Oh, okay. This is where it's coming from.
Yeah.
Okay.
Yes.
Varying the. Okay, got it. Sorry, I missed
Yes.
that.
Yes.
I
Yeah. We
appreciate
try to bring some heterogeneity
Okay.
in it.
Got it. Got it. Thank you very much.
Okay. All right. Okay, I'll continue then. Okay,
Hey,
so
Tong, I actually had a question really quick.
Okay.
So it seemed like the teacher LLM just is better at conflict resolution as based off of human evaluation. So that's the case. Like, I'm just wondering because LLM responses can vary wildly, even if there's like a few differences in prompts. So to me, it seems like it'd be really hard to cover the whole search space if that's the case. So what is the actual cost difference for using just a teacher LLM if it just leads to better conflict resolution if that's the case?
it costs per if you deploy it, like in the sense you mean like on a like when you want like a cost breakdown for like a annual cost difference?
Yeah, like what is the actual cost of like if conflict resolution is indeed better, like what is the price that you can put on that if like if the student LLM is just worse at resolving these issues?
I see. We don't have the cost for how much you actually pay for a decreased, but this is like, this is how much you would actually like people actually paying right now for their the annual cost for maintaining a cost center. So what I want to say is that actually there's large volume. You have like 1,000 calls per day or even more. So 1,000 call, like one call could involve many turns of the dialogue, right? And then I don't have the math here, but we can do some math. Yeah, but I don't know how much, we don't have the cost for, if you do not perform well, how much that is going to translate into the loss in customer value or something. We don't have that, but
I think if look, if this does well for 90% of the cases, I think you can add mechanisms as to if you are now in a space where nothing is close to you in the embedding space, just deploy the teacher.
Right? Yeah.
So if 90% of the cases the student can handle everything with this RAG thing, that's great, right? If in 10% there is some check that you can detect, right? All right, I'm really off the path. I can't find anything in this sort of strategy space. Just deploy the teacher.
Right. It's
That's
like a hybrid.
that can be done, right? And I think the cost savings are huge.
Yeah, I think it's a
That's
hybrid
true, yeah.
system. I think a lot of the state-of-the-art large language models, they are not relying on just one LLM. In their backend, they actually have many hundreds of smaller LLMs. They activate whenever they feel appropriate. Now we can use the idea here when for easier cases, easier determined by the test case is very similar or very close in the embedding space to the scenarios we stored. Then we activate this student LLM. But just as Ali said, if this distance is so large, and then we know that student might not be capable, then we activate the teacher LLM.
Tong, questions from the audience from Minha Wang. Wondering whether you've considered a hierarchical approach where you expand from higher level topics.
What do you mean by, I need some clarification. What do you mean by expand for higher topics?
I think this was related to, I think this is related to one of the previous slides. Or wait, I'm going to let Minhua post.
Okay.
Okay.
I want to follow up a bit on the like when do you activate the more complicated models? Because in like if we're considering that possibility, I'm just wondering for the basic advanced GPT-4 model, it seems that they can also have that ability. And if in this process, like we're not actually providing new data, then like what is the implication? Is the implication that, for example, GPT-4 like has not thought carefully about the customer service area and have not used that like thought it carefully enough to be able to answer the questions, or is some other like new additional value that we're providing? Like for example,
The value is to save costs such that we can get smaller models just to work as the GPT-4. So GPT-4 is, we think of it back then, GPT-4 is the best. We think of it as a state of the art. But there are motivations for sometimes to using smaller models for like safety issue or for cost issue, right? So the whole project is about how do we get a smaller model to work as close to the state-of-the-art LLM as possible.
Yeah, I think like maybe it's more of like why doesn't GPT-4 can also have the ability to determine this is an easy to answer question, so I'm going to activate a smaller model. Like what prevents it from that it to have that ability? Is it because that it doesn't have this ability to kind of evaluate?
It does, but you have to send the input to GPT-4. If that goes through, that generates cost, right? The motivation for that is that you don't use a state-of-the-art, the bigger LLM, the costly LLM. Try solving everything with smaller LLM, right? So the delegating work should also be done by the smaller LLM. Yeah, because there are costs in sending the input and also generation. There are two costs. So basically, we try to minimize the cost if we do want to use the hybrid. Yeah.
Thanks.
Okay.
Sorry, quick question.
Yeah.
When do you stop what was the criterion for stopping that student is good enough?
Oh, we use the scoring model. Basically, we ask we use LLM to evaluate based on some good examples, and he will provide a score of how good the answer is.
Right. So then I think it goes back to, I think also Minha also asked is like, when do you know it's what is the validation there, internal validation, because it's all depending on the LLM's, GPT-4's opinion of, this is good enough.
For training?
Yeah.
Yeah, for training. So we basically, the other way we consider this is that we look at the similarity between the output and the teacher's output. So it's a combination of the two. One is that the GPT-4 has a criteria, and the other one is that how we basically look at the cosine similarity between the student output and the teacher's output. So in either plateaus, there's no improvement. So we stop.
Tong, I promoted Minha to a panelist just to clarify some of the questions that he had.
Okay. Okay.
So can you hear me?
Yes.
Yes.
Yeah, so my question is about two things, about the validation, and the other one is like maybe slightly different approach. So let me start with first. So for this kind of thing, like LLM judge, LLM is kind of chicken and egg in some sense. So usually you need manual human data to validate. So I was wondering, how would you go about this?
Yes.
Did you create some ground truth set to validate or some other approach? So that's first question. And second question, what I meant by higher level topic is customer service different areas, right? It can be refund, cancellation, website problems. So what you can do is like starting from that as a seed for the topical area and expand from that, right? So that could be, more time saving for exploration as a seed, because random seed is kind of random, right? So I was wondering whether you consider like hierarchical approach.
So the first one, yes, actually I'm going to talk about that in the next slide. We have some human evaluation. For the second one, I'm trying to understand what exactly is the question. Are you saying that we could feed some data to the LLM as seed data when he does data generation?
No, what I meant is start thinking about what are the typical topical area for the customer service first, right? And then you can actually generate your kind of explorations within that each sub areas. That
Oh,
will
I
be more
see.
effective, right? Compared to
I see.
randomly doing this, that can be very data,
Yeah, you can do it. So if you
Yeah.
want to do it, just basically change the prompt and then adapt it to the context that you are interested in. Yeah.
But that
Yeah.
would be just for like human interpretation, right? I mean, like the LLMs don't really care because it's embedding based.
Right. Yeah. Okay, let me talk about the human evaluation. So you see there are two different colors. Each of them is the comparison against the teacher LLM. So the orange means, for example, here it means like only 3% of the time, Llama 2.7b, their base model is selected over GPT-4, only 3% of the time. The yellow means after we use our method with the knowledge, the percentage increased to about 35%. Okay. And you can see that across all student models, there's improvement. But of course, we're not doing better than GPT-4 because if we're doing similarly, this percentage should be 50%, right? That's like 50% time you're chosen over the other one. But we're not. But you still see that it's getting closer, right? We're reaching 40% compared to GPT-4. So this is evaluated. Each model is evaluated by 32 participants. So there's a total of 8 times these many participants in evaluating, getting these results. And because human evaluation is costly, so we are thinking if there's a cheaper way of doing it, so just as a robustness check, does it really improve? We can, for example, we can provide some GPT-4 generated examples as good examples and do things like a few shot evaluation. And so this is what we get. We use GPT-4 as an evaluator for the student model. So this is the average satisfaction. The two plots are basically different types of customers. I'm not going to get into the details now. So for the first one, you see that you don't see much improvement because they're already reaching 5. 5 is the maximum. And the other thing you might wonder is that you might see that the numbers, you might think the numbers improvement is not much, right? How meaningful is it? So the other metric we evaluate is that percentage of fives. Because in customer rating, many times people rate only like 4 and 5s, especially unless they're really, really pissed off, they will get a very low ratings. So that's why we compute the percentage of 5s because we're thinking as long as you're not getting the perfect score, there must be something that make you unhappy, right? So the other metric we evaluate is the percentage of 5s. So there's still significant improvement over the base model. Okay, yeah, George?
Well, I'm just wondering like how to interpret these results because there are still significant time where the student agent is selected over GPT-4. Should we think of this as that the GPT-4 weakly dominates the student's model, or should we think of this some evidence that maybe that there are some cases where the student model is outperforming the teacher model in some subset of scenario or for some subset of population? Because if that's the implication, it seems that like maybe there are like potential room for improvement.
Yeah, so
maybe
we
can
are
look at
trying
this
to
even.
get model that performs better on average. But even you see that even the best model, like GPT-4, it does not guarantee like on every cases, on every customer, he is preferred. So, but one thing is that we can say that it's on average. So that's the goal here. Maybe for different types of customer, maybe they will need different LLM, but that is it's slightly beyond this the scope of this one.
Because the implication is going to be different whether there are complements or substitutes. And I think also we are considering cases where assuming that the teacher model is dominating the student model in every aspect. But I'm just wondering like, what if the student-based model like actually outperforms the teacher model in some subtopics?
In some topics, but not average. Well, unless there's one way to deal with that is that if we have the human evaluation on every training cases, when we have the student output and teacher output, we let the human pick the better one. And we only distill when we know for sure teacher is better, but that will involve, a lot of the human labeling. That data is hard to get. So this is, yeah. So that's basically distilling not only from LLM, but also from human. So, yeah. Okay, Emma?
Yeah, a clarification question about this slide. What was so when you say better, what was the grading sort of criteria provided to the prolific
We
participant?
ask the human. We provide two conversations and say both are these are two agents interacting with the customer. So you, as a customer, which agent do you think is better?
Okay, so it's
We're not telling them what they think they should be better. So they're using their own common sense of determining which is better.
got it. That makes sense. And just to note, we have 15 minutes left.
Okay.
Right.
Okay.
Thank you.
Maybe, yeah, let me finish this and I'll briefly talk about the other one because they are the same theme. Okay, so this is the percentage fives. And we also compare with fine tuning, right? Directly get the teacher output and not getting the strategy, but directly fine tune. So you see that when the model is very small, fine tuning is actually better. But as the model size starts to increase, you'll see that it decreases. This is consistent with the curve here, right? As the model gets larger. So following the instructions is better than directly fine tuning because you could be expressing a similar idea, but saying different words. Okay, so this is a comparison with some global knowledge where, we come up with like a global guideline and it performs worse because, in our case, each strategy is customized for different scenario. And then they could provide different instructions for different cases. Okay, I think I'm going to skip the rest. I'll briefly talk about the other one because I think it's a similar. Can you see the other one? Okay, so this one is how do we utilize knowledge for slightly different application of content generation? And specifically, we're interested in generating the headlines. And first of all, what we observe is that if we want to use off-the-shelf LLMs, it do not perform very well because it's not because they are not capable. It's not because it does not have the knowledge, simply because it does not really understand what you mean. So it does not understand what exactly are you looking for in this context. So this is what we call a knowledge gap or a cognitive gap. And we can bridge the gap using fine-tuning. Okay? And then for this project, we use the Upworthy data where for each article is associated with multiple headlines. And in addition, we also supplement the data by crawling the article content. So here we know, just like in the teacher-student cases, we know what is a good answer. Now, in this A/B testing, we know what is a good headline based on the click-through rate and what is a bad headline. Okay, so how can we utilize this? And the use case is that we want to improve fine-tuning. The fine-tuning is challenging because there could be many different existing, many mappings. Mapping means a model that takes in our article and produces a catchy headline. But there are many passes that lead you from one article to the catchy headline, but not all of them are really robust and generalizable. So if we know something, if we have some knowledge about what the ground truth mapping should look like, can we utilize that knowledge to guide the fine-tuning? That is the idea, and that is the purpose of extracting the knowledge from the Upworthy dataset. So here, what we want to get is the theory, which is a set of instructions or guidelines, just like the strategies in the previous case. For example, we could say, use intriguing or unexpected language to create curiosity. Okay, and that will be like placing a prior over the ground truth mapping. Okay, so the problem is, how do we get that? I'm going to skip this and talk about this. How do we do that? So if you look at this, so this is actually similar to the previous knowledge generation. We have a definition of what is good, which is defined by the click-through rate. And the other definition of the other thing is the worst one, right? Also by the click-through rate. One is higher than the others. And we simply ask the LLM to work as adaptive reasoner. Propose hypothesis, try to explain what makes this headline better than the others. Just like in the previous case, what makes this response better than the other agent's response, right? And in addition to that, this is purely based on the data. This is a data-driven hypothesis. The other source of hypothesis is that even without the data, we know that LLM are very smart agents, right? Without providing this data, he has seen a lot of data already, so has some knowledge in his head. So we can also ask LLM just to propose some guidelines or instructions on how to create good headlines without showing him the data. All of them enter a pool called pool of hypothesis. There are hundreds of hypotheses or even more than that, okay? So this project and the most important part is how do we find the best theory, which is a list of hypotheses from the pool set of from the entire pool of hypotheses. And we need a metric. How do we know whether a theory is good or not? We can simply include a theory in the prompt and ask LLM to generate headlines now following the proposed theory, and then evaluate the headlines. And the quality of the headline represent the theory. Okay, I think I don't have time for much of the detail. So, okay, so this is what the framework looks like. We first propose hypothesis, and then look for the optimal set of few theories, a few hypotheses to form a theory from it. And this is the output of the algorithm. It will basically contain a short list of different hypotheses. So for example, they could say, highlight emotional reactions, incorporate a sense of defiance, create a sense of mystery or curiosity, and so on. So you can think of it as like optimized prompt for this particular task. And then later, what we do is that we include the prompt include this hypothesis and theory into the prompt when we do fine tuning. And this is equivalent to like placing a prior or regularization when we do fine tuning. And I'll directly show you some results. The green is without theory. We just do zero shot or few shot or supervised fine tuning or direct preference optimization. The DPO is a state-of-the-art fine tuning. And the pink is in adding the theory in the prompt, right? This is like adding a regularization. And you see that there is significant improvement of the performance. Okay, so here's some examples of the problem with the off-the-shelf GPT-4o and 4o mini. It's not because it does not generate good headlines. It's because the headlines are good summaries. But because GPT-4o does not know exactly what is our definition of catchiness, right? Which has to be learned from data. So that's why you see that in terms of catchiness, it does not perform well. So what you can think of this knowledge or theory is really an explanation of the metric. What exactly do we want in this context? That is the purpose of this knowledge we extracted. Okay, I'm going to skip. Okay, so the conclusion for this project, which I try to squeeze in two, is to try to say that LLM can serve dual goals. You can use it directly to solve the problem, or you can use it as knowledge extractor. And we propose novel method to elicit knowledge from LLMs and use knowledge to improve other LLMs. So the extract knowledge is interpretable to humans and also transferable across other different LLMs.
Tong, can I ask a concluding question?
Yes.
Okay, so like this idea that you generate something with teacher and then the student, and then the teacher goes back and you ask it to compare. To what extent does it depend on the teacher? You can ask the student itself, a new instance, to compare the teacher answer and the student answer and do this iterative process. The reason I'm asking is that I'm trying to see whether the gains come from the answer the teacher provided or the strategy that the teacher, because also the cost is much more dependent on this feedback thing, right? The cost goes down quite a bit if you just use the student.
Right. That's a great question. I think the benefit actually comes from two. First of all, the teacher's output is better. The other one is what we call the teacher is a better large language model who is better at reasoning, right? And thinking and try to identify the differences and come up with explanations.
But
That
learning
itself
the
is also better.
learning the contrast shouldn't be a very difficult task between the two answers, right?
But
So
it's not just trying to identify the differences. It's trying to identify like a reasonable explanation.
I see.
Yeah.
So you think it's you think you can't do as well? You think the gap is going to be very big if you use the model itself? Or have you
We
tried?
didn't
I'm just
try that.
curious.
I think, yeah, it will be an interesting ablation study. We could try that. Yeah. But my sense is because we empirically look at this, we actually tried like Llama 2 70B versus GPT-4. With that, we compared, and we think, you know, the GPT-4 is better at reasoning, like why these two is this one's better than the other.
Okay, cool.
I have a quick question for the second paper.
Yeah.
So I guess the contribution for the second is not only to extract knowledge interpretable to humans, but preferably that also second benefit is this theory, or through abductive reasoning, may make the distillation maybe faster for other LLMs. Have you tested, like when you have like small number of data sets, doing this would increase the performance, the efficiency of that?
Yeah, this is actually, I skipped. So we tried using different percentage of data. And yeah, this is actually, it is indeed better. The reason is because the knowledge, some of the knowledge are proposed with no data, right? We just ask LLM, think of something that, can get you good headlines. That knowledge itself is consolidated from thousands or more data that LLM has seen. That's act like substitutes of this local data set. I think that's why the performance improves.
Cool.
Tong, I have a question about the first paper, the evaluation protocol. So at a high level, what you're doing is you're training the student to mimic the teacher. And then in the evaluation, you ask the teacher how, I guess you ask the teacher which one is better. But I'm thinking, is that equivalent to just asking the teacher how similar are the two responses? Like if you just measure.
In the training, yes, because we're providing the teachers as example when we do like a few shot. So during training, the criteria is how good you are in terms of being similar to the teacher. Yeah.
But then in your evaluation, in the GPT-driven evaluation protocol, where you ask GPT to evaluate which one's better.
Yeah. But then we still give examples. So here, because here the underlying assumption that GPT-4 is better. Yeah.
Yeah, so I'm trying to think, is that mechanical? Because I'm thinking, what if instead of using the teacher model to do the evaluation, you use another big model like Llama?
We used Llama 2 70B, but we still need to provide examples. Otherwise, they don't know which one is better. So are you suggesting we could do like a zero shot evaluation, maybe
No,
to
I'm
reduce bias?
I'm saying when doing the evaluation, use a different model for the evaluation than the teacher model.
I see. We did. We used 70B. Yeah.
And the teacher
We
was
used both, actually. They're consistent. Yeah.
so 70B was the evaluator and GPT was the teacher.
In evaluation, we use both GPT-4 as the evaluator and 70B. I just didn't put it here, but as a robustness check, we use 70B as well.
Yeah, I was just like what I'm asking about is when the teacher and the evaluator are different, then how do the numbers change, right? So you use a different.
They're actually consistent. The improvement and the findings are consistent. They're just different scale. For example, Llama 2 70B, we find that it's more likely to give out 3 like odd numbers then. So the scale would be different, but the trend is the same. Yeah.
Thank you.
Does the result heavily depend on whether you provide the examples by GPT-4 for evaluating, or if you just do zero shot asking the GPT-4 to evaluate responses, one generated by GPT-4 and the other generated by the student-based model? So
we didn't do zero shot. We always provide an example, and if we provide different examples, the evaluation is different. That's why I showed 2 sets, because we provide examples from like interacting with different types of customers. But so we didn't do 0 shot. We thought we basically use like directly use human, like as if they're like a few shot, 0 shot.
All right, given that we're at time, I'm going to conclude the formal part of the presentation. Thanks, Tong, for this great talk, and thanks to all the panelists for asking these questions.